Could you please put a yes in the chat? All right. Thank you. Good evening again. Welcome to this Industry Collaborative Certificate course on Data AI by the Department of Mathematics, St. Thomas Corinjeri, and ipsr Solutions Limited. ipsr Solutions Limited. This industry by running this event. My name is Sijin Jacob George, and working as relations manager with IPS, and I will be the moderator. On to today's session, Docker development introduction. This is Jolsna N. She's a senior technical consultant solutions. Jolsna is an experienced IT professional specializing in web application deployment. It's strong AWS infrastructure. At ipsr Solutions Limited, advanced in Linux administration. She trained in dev and holds RFs and CE certificate. Personnel so in cPanel and WHM management and VMware virtualization. Known for her strong troubleshooting abilities, teamwork, and has received multiple awards for excellence and is committed. Over to you, Jolsna.
Thank you so much, Sijin. Is that my voice is clear? Hello? Yes. Okay. Am I audible, Sijin?
Yes. So please.
Okay. Okay. So, good evening, everyone. Actually, I'm sick today, so my sound is not okay. Please excuse me for that. Okay. Good evening, everyone. Welcome to today's session. In this class, we will be discussing the basics of Docker and containerization. So before we begin, I would like to know if anyone here already has an experience with a Docker or container technologies, or if this is your first time learning Docker, please let me know that in chat. Because that will help me to understand the level of the class and explain the concept accordingly. So that's why I'm asking. Okay, little knowledge about Kubernetes before. Okay, what about the others? First time. Okay, no issues. First time hearing about it. Okay, it's first time. Okay. So from the chat, I can see only few are responding, and in which one has the basic knowledge of Kubernetes, and others are, yeah, first time hearing about Docker or containerization. Okay, all good. Okay, so in today's session, we are going to discuss about what is Docker and why we need to use Docker. What are the problems that we faced before Docker or containerization, Docker architecture, and the important terms in Docker. So this is actually what we plan today. Okay, let me share my screen first. Let me share. Are you able to see my screen now? Can anyone respond? Okay. So, in today's session, we are going to discuss about what is a Docker, why we are using Docker, problems before Docker, and how we can install Docker, and the architecture of Docker, what are Docker images, and what is Docker Hub, and some of the basic commands also we will cover today. Okay, so what is Docker? Docker is a containerization platform that packages applications and their dependencies into containers so they can run consistently across everywhere. So here I said Docker is a containerization platform. So moving to the containerization platform, first we should have an idea about what is a container. Okay, so what is a container? A container, a container is a lightweight, portable environment. Okay, so in traditional application deployment, okay, developers or developers build an application on their system. But when they move the application from their machine to another machine, or to the staging, or to the development, or to the production environment, or to the staging, some if there is a dependencies issues, or if there is any environment changes, then it won't work. Okay, or in our machine also, suppose I want to create an application with Python 3 or some Python version, and again I want to build another application but which is using an older version of Python or the latest version of Python. So at a time you need to run two different versions of Python. And again, if you want to run an application which is using another language like Node.js or Java, so if you want to run multiple languages or multiple libraries or multiple dependencies, then we couldn't achieve it. Like we can't host all the applications in a single machine. So what we can do, either we can reconfigure our machine such a way that only one application will work at a time. Okay, in that way we can reconfigure our machine. But most of the time we face some issues, like if you want to work with the three applications, uh, like we may face many issues because of that. So, what a container will do is a container will package everything needed for that application, like application code, the runtime, the libraries, the system tools, and everything needed for that application, that they will package together. Okay, so if you want to run this container on a Windows machine, yes, you can run that one. If you want to run your application in another machine, yes, you can run that one. Or if you want to execute this on a Mac machine or on in a Linux machine, everywhere, without any issues, we can run this application. Okay, so a container will package all together. So we can run anywhere. We can run that application anywhere. We don't need to worry about the environment. We don't need to worry about the dependencies. We don't need to worry about the libraries, or we don't need to worry about the runtime. We don't need to care about anything. So the Docker need to be installed in your machine. That is the only thing that we need to that we need to do. Okay, so we need to install Docker in your system. Then anything can be run if it is containerized. Okay, so before Docker, like I said, so if a developer if a developer deploy, or if a developer build an application, and that
Jolsna, can you put that on presentation, your slides?
it is not visible. Is that not visible?
Slides
Hello.
are visible, that's fine, but make it on presentation mode.
Okay.
Yeah, your slides are visible. Just put the slide on, put it on presentation mode. It's F.
Yeah, sure. Okay, let me check. Let me check. Okay, now, right?
Yeah, fine.
Okay. So before Docker, what I was saying, so in traditional deployment, developers build their application on their system. But when these application need to be tested in a different environment, or if it is need to be moved to the production environment, if there is any environment changes, or if there is any dependency changes, then it won't work. So what the developer will say, yes, it worked on my machine, so there is something issue with your setup, so there is something issue with your production server, or there is something issue with your testing environment. So my application is okay, it is working on my machine. So this kind of blaming occurs before Docker. And also, it was very difficult to scale our applications. Okay, so before Docker, we introduced, like, the IT team introduced virtualization technologies to solve these issues. Okay, so virtualization technologies were introduced. So in our machine, the main physical machine, on top of that, okay, in our physical machine, we may need to install the operating system and all the infrastructure we need to set up. On top of that, we may need to install the hypervisor means a tool which enable the virtualization. We have many tools like VMware, VirtualBox, KVM. Many tools are there to set up virtualization. So we can install a hypervisor or virtualization tool on top of your machine, and in which we can create many virtual machines. So in the first image, you can see that. So here, this is the setup of virtualization. So in virtualization setup, we first create a virtual machine, and we can install whatever or what operating system we want. Like if it is Windows, sorry, if it is Windows, we can install Windows on the virtual machine. Or if it is a Linux machine, yes, we can install any operating system that we can install on top of our hypervisor. And based on the application that we need to deploy, we can install the packages and libraries, and we can deploy our first application. Again, if you want to set up another application in the same way, you can create another virtual machine, and on top of that you can install the guest operating system and the packages which is needed for the application too. Like that you can create whatever applications that you want to host. Yes, you can create. But here the thing is that when you are creating virtual machines on your main machine, that will make our main machine little bit slow. Not little bit, based on the sorry, based on the resources of the main machine, we can create the number of virtual machines. Like if it support, then we can create 4 or 5 virtual machines. If the resources are very high, then we can create 10 or 20, or like that. We can, based on the resources of the main machine, we can create a number of virtual machines. Here, yes, our like uh, what we want is achieved by this virtual machine setup. But the thing is that it makes little bit heavier. Like here, many operating systems we are installing on top of our main machine, so this make our machine heavier. Okay. And also the main machine, when something happens to the main machine, all virtual machines will go down. So these were the issues that we faced with the virtual machine setup. Then we introduced containerization technology. So in containerization technology, like we did in the previous virtualization setup, yes, we need an infrastructure. On top of that, we are installing operating system. And here, we don't need any hypervisors. We are installing container engine. Okay, so we already said that Docker is a containerization platform. So Docker is a container engine. So we are installing container engine on top of our operating system, and we can execute or we can create containers on top of that. So we will get an isolated environment for for all the containers. So all these containers are in an isolated environment. Like we as the name suggests, the containers means, yes, it is a container, like the containers that we transport, like with the ships and with the cargo, we transport containers, right? So we don't need to care about what other containers included or what other container consist of. We don't need to care about that. We only care about what is inside our container. So this is the setup what is in containers. Okay, so in VM it has full OS. So VM is very heavy because of that, and also it is slow. So in containers, it shares the same host operating system, or it shares the same kernel. Okay, it shares the same kernel. So the containers are lightweight and very fast. So VMs are like a hardware virtualization, and containers are OS level virtualization. Okay, so VMs virtualization means, yes, physically we have only one machine, but virtually we are getting more machines on a single machine. Here also, in containerization also, yes, we are getting virtually, we are getting many machines, or many containers. We can run many containers. It's a noise level virtualization. Okay, so anyone can run containers anywhere. So that is the main advantage of Docker. And it is lightweight compared to the traditional setup or to the VMs. And the startup is very fast and easily. We can scale the machines very easily, or we can scale the containers very easily. And in the DevOps, currently all are into the DevOps. So in DevOps, we can integrate these containers easily. We can do the CI/CD integration easily with containers. Okay. So again, what is a Docker? So I already said Docker is a container platform. Okay, which is used to build container images. And if you want to run containers, yes, we can do it with Docker. And also the Docker are used to manage container lifecycle. Okay, many container engines are there. So Docker engine is the most popular container engine. And container D, which is a lightweight container runtime, originally developed by Docker. And there is Cryo, a container runtime designed to specifically for Kubernetes. Okay, so we and also we have Podman, that is also a container engine, which is created by Red Hat. Okay, and also the Podman is a daemonless container engine. So many container engines are there, but the most popular one is Docker engine. Okay, this is the Docker architecture. In our machine, we may need to install the Docker engine first. Okay, we need to install Docker engine first. Then from our machine, we can use Docker command for building the Docker images. And if you want to run containers, we can use Docker command. Or if you want to pull images from the Docker hub, yes, you can use Docker command. So these are the Docker CLI commands: Docker build, Docker pull, Docker run. These are the commands which is used to manage containers. Okay, so when we are using Docker, basically, when we want to run some containers, the system will check in the Docker hub first. So Docker hub is a container registry. Container registry means here we already said that containers are lightweight. Why? Because we are using container images for creating containers. So these images are lightweighted. And these images are stored in Docker registry. Okay, or in the Docker hub. Docker hub is the default one. Or if you are building your own images, either you can push that images to the Docker hub or your private repository or private registry. Okay, I will show you a demo on that. Okay, so in Docker, these are the important terms that we need to know. Image. So I already said that Docker images are used for creating containers. So what is a Docker image? So Docker image is like a blueprint of your application. So you create a file and you put all the details, all the wanted details in your Docker file, and with the Docker file you create your own image. Okay, so these images include everything which is needed for that application. So that's why it is saying the image is a blueprint of your application. And with that image, you run containers. So the running instance of a container image is called container. Sorry. And in Docker file, you specify the instructions to build your image. So we will go to a demo for all these. I will show you what a Docker image is, what a container is, what a Docker file is, how we can get an image from the Docker hub or from my container registry. I will give you a demo on that. Okay. So let me first uh, create an instance for you. Okay, so this is my AWS account. So I'm not creating any containers in my machine. Yes, if I want, I can create my containers in my machine. But in today's session, what I'm going to do is I'm going to create an instance. An instance means a machine in AWS. Okay, so even though if your machine is is not having good spec, then you don't need to worry about anything. You can create AWS account, or you can create a Google Cloud account, or you can create a Azure account, or you can create DigitalOcean, or many cloud providers are there. So in that provider, you can create instances, you can create machines. So here I'm just specifying the name of my machine. So when I am specifying the name of my machine, so what it will do is, here I'm going to specify some of the characteristics of my instance, or some of specifications of my machine. So with that specification, my system or this AWS will provide a machine or virtual setup or virtual machine in the North Virginia region. So in AWS, or AWS have data centers in many regions. You can see here a list of data center regions are here. It is listing. So in the United States, North Virginia region, I am creating my machine. Okay, I'm creating my machine. So what AWS will do is, based on the specifications I have given here, they will allocate a machine for me. So I can access that machine via remote. So this is actually what I'm going to do. So here I'm creating a machine called Docker, and also I can specify what operating system that I want to install in that machine. Either I can go with Amazon Linux or Mac OS, Ubuntu, Windows, Red Hat, SUSE Linux, Debian. All the versions are listed here. So here for this demo, I'm going with Ubuntu. Okay, I'm selecting Ubuntu as my operating system. And here you can see the instance type also I can specify. In instance type, that you are specifying what specification that you want to provide. So here I need only 2 virtual CPUs with 1 GB of memory. So this is the minimum requirement of mine. So if you want a high spec machine, so you can go for T3 micro or T3 medium or C5, or many type of instances are there in the AWS. So you can select what instance that you want or what spec that you want. So here for this demo, I only need a machine with the 2 virtual CPU and 1 GB of RAM. So I'm going with that one. And for the secure communication, it is asking for a key pair. So I'm selecting one which is present in my system. And also I'm selecting the security group. Okay, so within seconds, when I click on that launch instance, within seconds my machine will get ready. Let me check. Okay, so there is an issue with this account. Okay, let me create it again. Hmm. Okay, let me check how many instances are running in my AWS account. Then, okay. So in Mumbai region, there is one, there are three machines in this machine, or I mean, in this machine, sorry, in this account. That's why. So it was working. Okay, let me go to the another account. Okay. Uh, Let me stop sharing first. Then I will log into another AWS account. Then we can do the same. Okay. Just a minute. I will log into another AWS account. I'm almost there. Okay, I log into another machine. So here we can launch an instance. Okay, it won't take that much time. So within a few clicks. Okay. So you can see within a minute I can launch my instance. An instance means a machine. So, with the specifications I provided in the AWS console, the AWS provided a machine for me to do all these things. So you can create the machines that you with your specifications. So here I'm going to connect that machine remotely. For that I have git bash for here. You need a bash or terminal for accessing this one. So here I have git bash. So what I'm going to do is I'm logging into my machine. Okay. Okay. So is this size is okay for you? Is that visible? Is this size is okay? Okay. 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 So in this machine, when I'm checking the docker hyphen version, docker command is not found. Docker is not available in my machine. I just created this instance for the demo purpose. I haven't installed anything in this machine. So, in your Windows machine, or in your Linux machine, or in your Mac machine, anywhere, if you want to install Docker, just go to the just to go to the docker, not the docker.com, docker install page. So it will take you to the docs.docker.com. Okay. So in this is the official documentation of Docker. So here you can see, you can select the OS where you want to install Docker. So here I launched a Ubuntu instance. So I'm going to refer this page for installing Docker. So if you are using Debian, you can select the Debian. Or if you are using CentOS, you can go in that way. Or if you want to install Docker in your system, either you can sorry, you can go for Docker desktop for Windows. So this is the Docker desktop for Windows. So either you can install that one also. So here what I'm going to do is I'm going to install Docker in my Ubuntu machine. So first I'm going to copy this command and pasting it here. You don't need to worry about the command and all, because I am also just copying the command from the official documentation page and pasting it into my machine. So if you are using a Linux machine, you also need to do the same. You only need to copy the command from the official documentation page and paste it into your um, in your machine. Okay. We can wait for the installation. Okay. One command also need to install. Okay. So successfully installed Docker in our machine. Okay. So now when you use docker hyphen version command, you can see the latest version of Docker is installed in your machine. You can see the Docker version as 29.3.0. And if you want to run the command, here you can see they are also providing some commands for starting the starting the Docker service, and also again one command for checking whether the Docker command is working properly in your system. Here, when you execute this command, you can see yes, it is working properly. Then you can check Docker ps command, but when you run the Docker ps command, you can see the permission denied issue. The permission denied issue is happening. Why? Because here I am accessing my machine means this particular machine as a normal user, not as admin user. So some kind of permission issue is happening in my machine. So what I need to do is, so I'm executing one command, that is user mode command. um, this is for adding my user Ubuntu. This is the user that I am currently working. So that user need to be added in the Docker group. Then just exit from this machine and again log in. Then after executing this command, you can check the Docker ps command, Docker ps minus a command. These all commands will work properly. So you may be confused with these commands. Why I am executing these commands in my machine? So I will show you how a container work, how we can access a container, and how we can create our own container images. So these are things that we will cover today. Okay. So when I check for the Docker images available in my machine, you can see Docker images will list the images available locally in your machine. So in the previous command, you just ran, I just ran the command docker run hello world. This was the command that I copied from the official documentation page. Then I pasted it in my machine. So when I executed that command, here doc hello world is the image that I want to that I needed for running that container. So what my system did is it checked the Docker Hub. So Docker Hub is the container image library. Okay. So when I check for hello world, yes, you can see the hello world Docker official image. So when I executed that docker run hello world command, what my system did is it communicated with the Docker Hub, and it pulled that image from the Docker Hub. Okay, again, we can try another one. So here you can see only one image is present in my machine. So when I use docker pull and some other image names, like suppose if I want to pull nginx image, yes, you can see it it pulled that image from the Docker Hub. Now, when I check Docker images, now you can see two images are available in my system, and which one is used, one is in use, the other one is not using. So here docker ps command is for checking whether a container is running or what all containers are running in my system. So docker ps command is for checking the available containers or the running containers. So docker ps minus a command is for checking which all containers are in the stop state. So this hello world container, this hello world container is in the stop state. So what I can do is I can remove if I want. So I just I'm removing that container from my machine. Docker rm and the name of the container, this is the name of the container because I haven't specified any name while creating that container. So this is the command. And if you want to remove images, what you can do is docker images. And if you want to remove the images, docker rmi, then you can specify the image name. Again, if you want to remove the other one also, you can use docker rmi. So there are no images present in your system. So you can create images, you can pull images, you can remove images, anything can be done in your system. Okay, now I will show you how we can run a container. Suppose if you want a web server, you want to host something. Okay, you want to host something, some application need to be hosted in your system. So here in my machine only docker is installed. I'm not installing anything. I'm not going to install anything. But if in this machine I want to host something, like I want to host some application, suppose I want to host a web server, then I will show you how I can do that. So for that, docker run command. So if you want to run a container, then you need to use docker run. Then you can specify minus d command. This is for detached mode. So why I am using detached mode is because I need to use the shell prompt after running that uh, container. Otherwise, my shell prompt will get stuck. Okay, so that's why I'm using this one. Hyphen hyphen name web server. This is the name of the container that I want to create. So this is the name of the container. And I'm also specifying some port number also here. I will show you why I'm specifying that port number, and what all port numbers that I am specifying also I will show you. Okay, then I am specifying the name of the image that I want to use. So you know that in my machine currently there is no local images. So when I execute this command, the system will automatically check in the docker hub for the image named nginx full colon latest, and it will pull that image to my machine. Now you can see when you check the docker images, it will list that image. Because when I was executing that command, this particular command, that image was not present, but system automatically checked the docker registry and pulled that image into my machine. And then with that container image, my system, okay, running a container. So now docker images will list the container image. Now when you check docker ps command, you can see a container is running in my system, and the name of the container is web server. So if I want to access that container, this is the public IP address of my instance that I launched in AWS. So when I copy that IP address and paste it in the browser, you can see Hello? Is anyone saying anything? Hello?
No, Jolsna, proceed.
Okay, okay, okay. Okay. This was not available in port 80. Let me check. Okay. So let me check Docker inspect the container image. So whether if this image is using some other port, let me 80 is the port number. Okay. Okay. What I can do is let me Docker PS. So Docker stop. I'm just stopping that machine web server and Docker RM web server. Okay. Again here, let me try some other port numbers. Normally it will work, but I don't know why it is not working. Let me check the let me check the security group whether any port related um, all traffic is open. There is no issues with that. Hmm. Why the issue was, it was actually redirecting to https, that's why that page was not visible. So now this page is accessible. Let's I'm sorry. Okay, now you can see the page that I hosted. Now I can see from my web browser. I haven't installed any Nginx, or I haven't configured any configuration related things in my machine. What within a single command, I only did this command docker run minus d hyphen name web server, then minus p, that port number also I specified, then the container image. Here this nginx latest is the container image, is a container image that I used. So when I execute this single command, I got a web server. Okay, I got a web server. And if you want to if you want to change the content, or if you want to change your own content, or if you want to modify the content, yes, you can do that one also. That you can do it with docker execute interactively, then the web server is the container, then bin bash. Then you can check here. We have, sorry, echo. I'm just putting a hi message. So USR share within this index.html file. I'm just putting a hi message. So now when I refresh, you can see only that hi message is listing. So you can change the content of that container. If you want to if you want to put some HTML codes into this machine or into this container, yes, you can do that. I will show you how we can create our own images. Here, in this example, what I demonstrated, I was using some images which is available in the Docker Hub. Okay, so the images which is available in the Docker Hub are created by some other developers or some other DevOps teams for their needs, and we will get many Docker images here from the Docker Hub. So if we want, we can customize these Docker images. We can create our own contents. So I will show you how we can create our own Docker images. Okay, so I will show you. Okay, so I'm creating a folder. This is the project one. Okay, this is the project one, and in this project one, I am creating an index.html. Okay, so in this index.html, like you can create what all HTML code that you want to run, that you can paste it here. But I'm not using any HTML code. I'm just putting some hi, this is my test page. So if you want, you can use br new page. Okay, so this is the content. Okay, so what I'm going to do is I'm going to write a Docker file. This is the file that we need to create in order to build a container image. So in which I'm specifying what container image that I need to use as a base image. So here I want to use Nginx as my base image. Okay, then copy the index.html file present in my present working directory to the usr share nginx html folder. Okay, this is the only thing that I am specifying in my Docker file. So I'm creating a simple Docker image. Now when you check Docker images, this is the only image present in your system. Okay. So Docker build -t, you can specify tag. Oh, this is the custom image. So I am specifying Nginx custom. This is the name that I'm going to give. Nginx custom. Okay, Docker build -t Nginx hyphen custom is the name. Then I am specifying a dot. This means you need to use the Docker file present in your present working directory. So when I am executing this command, you can see this will create a Docker image in my system with the name that I specified. So you can see nginx hyphen custom is the name. It is the name of the image that I created. Okay, this is the name of the container image. So with that customized container image, I'm going to create a container. So again, Docker run -d hyphen name. Last time we were using the name web server. Now we are using custom hyphen web as the name. And also I'm specifying the pod number, which is 8081, and the image that I want to use is nginx-custom latest. This is the image that we created or that I created just now. So when I am executing this command, the container is up and running now. You can see docker ps command will show you the custom web that container is now up and running. So this is the container that was present previously. Now you can run another container with another content. So now in my machine, two web servers are running with in different pod numbers. Same machine, but with in same machine, but with different pod number. Two different containers are running. Two different web servers are running. So it is very easy. I'm just copying or I'm just using a simple text file to host pages. So, like you are developers, you have the idea how to write HTML codes, how to like use Python, or even though if you are not developers, you can simply go to Google and you can ask for the codes. Then they will provide code. Then you can use that codes. Okay. Okay. So, do you have any doubts till the topics, like if you have any doubts till now, then you can ask questions. Then we will go to the other parts, like I'm going to demo a Python app, how to containerize a Python app. That will also I will demonstrate. So before going to that, if you have any doubts, you can raise your question, then we can move forward. If you have no questions, please comment that one also, then we can move. No doubts. Okay, what about the others? Okay. Okay. Okay, I hope we can move forward. Okay, so the next one that we are going to demonstrate is how to containerize a Python app. So now here you can see we have two containers. These two containers are just a simple web server. So if you want to containerize a Python application, so I'm going to create another folder called project 2. Okay, within that project 2, we can create our Python app. So here we need to write our app.py. This is the main file for our Python application. So I have uh, some code here. This is the code that I just copied from the internet. Okay, just to print hello from Dockerize the Python app. So like if you are very good in Python, then you can write your own code. Okay, so you can write your own code. This is very simple code. Okay. This is very simple code to print hello from Dockerized Python app. Okay, so I just wrote my app.py and I am writing my requirements.txt file. This is for specifying my application, like this is for specifying my requirements. So I just wrote my app.py, I wrote my requirement.txt file. Now I want to write my docker file. This file is very important for creating your image. So here you can see this one also, this one also very simple one, then I will explain. Okay, so here you can see from Python 3.10 slim, this is the official Python image that I want to use. So when I use that Python image, it will uh, this Python image will include all the runtime, dependencies, libraries, everything needed for like executing a Python application. So I am using that Python 3.10 hyphen slim as my um, base image, and setting up my working directory as slash app. And I want to copy my requirement.txt file also to the docker file, and I'm copying my like here copying my requirement.txt file to the working directory, and I'm installing the what all requirements that I specified in the requirement.txt file. So I'm running that pip install command also with this one, and copying that app.py also to the working directory. I am exposing the port 5000 here. So I want to expose the port 5000. Then this is the command that I want to run, python app.py. This is the command that I want to run. So let's create our image. So these are the three files that I created. Then docker build minus t and the name of that image. So python hyphen new is the name of the image, then dot, which means we need to use that docker file. Okay, so here you can see what all commands that we specified in the docker file. It is execute one by one. You can see it is pulling that docker.io library python 3.10 hyphen slim from the docker hub, and setting up a working directory as slash app, and copying our requirement.txt file, and it is installing the requirements from the requirement.txt file, copying that app.py file. Everything is done now. Now when you check docker images, now you can see the python hyphen new image is available in your system, which is not in use. So we can create a application, like we can run a Python application as a container here. So docker run minus d hyphen hyphen name python hyphen app is the name of our container with the minus p. So here we are using 5000, and also we can specify other port number also here as the host port, but I am not using that one. Okay, this is the image that we want to use. Okay, now with the IP address of that machine and with the port number, you can see this is the Python app that we just built. Hello from Dockerized Python app. since here I am using a simple Python code here, that's why it is only listing this one, all it is only printing this one. So if you are a developer, if you are good at Python, then you can build your own app and you can containerize it. Okay. Okay. So you can see Docker PS command. You can see 3 containers are running in your system. Okay. Any questions regarding this Python app? Any questions? No. Okay. So the next one is, this is the way how we containerize your application. So here you can see that here last time when we were using that project one, sorry, project one, here we wrote a index.html file. We wrote an index.html file. But if you want to make some changes in the index.html file, okay, hi, this is the content that, or we are, or this is the new content. Okay, so I'm adding this content also in the index.html. But when you try to access this page, it is not reflecting. The changes are not reflecting. Why? I modified that index.html file, but it is not getting reflected here. Why? Because we already created that that nginx hyphen custom image earlier. Then while creating that image, it copied that index.html file. So if you want to make these new changes into the live server, what you have to do is you need to create a other image, and with the latest image you need to build the container. But that is not easy when it comes to production. So each and every time when developer pushes something into the code, or into the or the developer makes some changes, each and every time building new image and restarting the container, or removing the old container and starting a new container, that is not a good practice. So what we can do is we can mount the container volume. We can mount. So I will show you how we can mount. Okay. So docker run minus d hyphen hyphen name new. This is the name of the container, and I want to use minus p 9090 as the 9090 as the port. Okay, and the image that I want to use is nginx hyphen custom. This is the image that I want to use, but I want to add some other details also with this container. So I'm specifying minus v. So minus v means volume mounting. So I'm saying data, or we can say what other name? Yes, just data, then slash usr share nginx, then share nginx html. This is the folder that I want to mount. So I'm just specifying the path also with the command. Okay. Now, with the port number 9090, the application will be available. With the port number 9090, the application will be available. So if you want to change the content on a real-time basis, what you can do is go to the var lib docker volumes, and in the volumes there you can see a data folder. Sorry, there you can see a data folder. So when you check the data folder, you can see, oh sorry, sudo, you can no such files, or var lib docker, in docker you can see the volumes. So volumes, there you can see a folder called data, and in which you can see a folder called underscore data, and in which you can see the index.html. So sudo vim, make the changes. I'm just putting some changes. Hi, this is the change that I made. So when you refresh the page, you can see the changes also. So when you make the changes here, when you edit the files, when you push something into the git, so the real time changes will happen. Okay, this is actually what we use in production environment. Okay, okay, these are the very Docker basics. But when it comes to the production environment, or if you want to work in your laptop, or if you are using a Windows machine, you can install Docker Desktop. Okay, so if you are not comfortable with command line, then you can install Docker Desktop. Here also you need to run some of the commands, like here you can see Docker run. If I want to execute nginx, you can see Docker run nginx. It will up a container in my Windows machine. This is my Windows machine, and Docker Desktop is installed in this machine. You can see on a real-time basis, I can see this is the running container. And if I want to stop the container, yes, I have the stop option. And if I want to delete it forever, yes, I can do it via graphically. Okay, so if you are not familiar, if you are not that much familiar with command line, then you can go with Docker Desktop. This is actually one of the developer tool. Okay, and here for this one, we just created a few containers. But when it comes to the production setup, okay, when it comes to the production setup, we may need to create an application, whether it is a monolithic application or it is a microservice based application. Monolithic application means the entire application is working as a single container image, and if it is a microservice, the application is divided into many parts, and for each part a different container may work for each section. So the architect decide how you have to develop your application. So if it is a microservice, then you may need to manage many containers that we may need to manage. Then in that situation, it is not easy to work with this Docker environment. Then if you want to scale it, if you want to like manage, if you want to deploy, everything that we can easily done with Kubernetes. So Kubernetes is a container orchestration platform. It is a container orchestration platform. Orchestration means to manage your containers. That is the main thing that orchestration tool will do. So the orchestration tool is Kubernetes. AWS is providing their service, like their Kubernetes service, their Kubernetes service as EKS. Azure also providing Kubernetes service as a, Azure Kubernetes service. Google is providing GKE. Okay, OpenShift is providing orchestration. Okay, so many providers are providing orchestrations. So if you want to manage all the containers in a better way, then you need to configure Kubernetes also. Kubernetes is the orchestration tool. Okay, so I will show you. If you want to move to Kubernetes concept, yes, we can move to that topic also. But before that, I will show you some other commands also for managing Docker. So Docker images command is for listing the container images, and Docker ps command is for listing our running containers. And if you want to list both the running containers and the stopped containers, you can use docker ps minus a command. And if you want to stop some of the containers, you can use docker stop and the name of the containers. Here web server is the name of the container, then you can stop the container, so that container will not be available in the docker ps command. But when you use docker ps minus a command, then that one also will listed, but you can see the status will show you exited. And in the same way, you can stop the other containers also, custom web. Yes, you can stop. Now that container also will show you as exited. So a running container cannot be removed with docker rm command. So here docker rm python hyphen app won't remove that container. This container is in the running state, so you have to stop it first, then only you can remove it. So docker stop python app, then you can remove the container. Let's see. Okay, so now when you see docker ps only listing one container, when you use docker ps minus a, you can see three containers are in the exited state. Then you can use docker rm python app, you can remove it. You can custom web, you can remove, and the web server also you can remove. So once you removed that container, then it won't list here. Only the running container is listing here. And if you want to get a detailed info about that container, then you may need to use docker inspect the name of the container new. This is the name of the container here. Okay, new. sorry. So you can see all the information about that container. This is the ID of that container. Okay, created date and time. Okay, this is the argument that we provided. It is in the running state. Okay, and this is the image ID that we used for running this container. And you can see where it is mounted, the host name path, the host path, everything that you can see. This is the bind map that we used, and also this is the port that we exposed. This is the host port. Okay, and also other details also you can see here. I'm just showing the only the wanted the main needed entries also. So the source file, this is the location where we mounted. So var lib docker volumes, within that volumes folder we added data folder, and within that data folder we can see underscore data. This name is the this data is the name that we specified in the command. Okay, and the destination was usr share nginx html. So in order to write this docker file, first you should have an idea about how this application will work. Then only you can create your docker file. So here when you use cat docker file, you can see only two lines are here. Only I am using the nginx latest image and also copying it to the document root of that nginx. Okay, so for this one it is very easy, but for this project 2, you can see cat docker file, in which we are adding more details, like we are specifying the working directory, we are specifying the files, which all files that we need to copy, and what command that we need to that we need to use for installing that requirements, and what is the command for exposing that port, and what command that we need to run here. So we should have an idea about this. So when you go to the docker, okay, so when you go to this docker page, and you can see the gate manuals. Okay, manuals, you can see the docker build, the building related things also you can see here. What is a multi-stage build, and also you can see the docker compose file. Docker compose file, actually the docker compose file is for running multi-container applications. So in your system, a application is running, and for that application the python app is working, and you need a database as the backend, and you need redis for the cache. So in that case you need to run many containers, like python container you need to run, the postgres or the database container you may need to run, and also you may need to run the cache related containers also. So running containers separately, so while we running separate containers, we may need to configure the connectivity between these containers also. So what we have to do is we can use docker compose file, and every container related, volume mounting related, the network related things, everything that we can define in the docker compose file. Okay, that is also a very good thing that we can use in the production setup. So within a single file, we specify everything, and we use this single file for starting the container, stopping the container, rebuilding the service, for everything that we need to use Docker Compose file. Okay, is this clear? Any questions? Any questions? No. What about the others? Clear. Okay. Okay. So let's move to the Kubernetes topic also. Why I am moving to the Kubernetes topic now is because um, Kubernetes is the container orchestration platform. Okay, it is the containerization orchestration platform. So Kubernetes.io is the official documentation page of Kubernetes. And why Kubernetes? Why we need Kubernetes is means the main thing is there are many reasons for Kubernetes or for the container orchestration. So if we have Kubernetes, then if something happens for our containers, sometimes it may fail, or sometimes it may get stopped automatically. So in that situations, if you configure Kubernetes cluster in your setup, it will auto healed. Okay, that it will try to heal the containers. If some of the containers stop, it will try to start the containers automatically. If some of the containers get failed, then it will start the container again, or it will replace the failed containers with the new one. Okay, or if some of the containers are not responding to the health checkup, then it will replace it with another container. And also many sorry, many things that we can do secret management easily with Kubernetes, and scaling can also be possible with Kubernetes. Automatic rollout and rollbacks. Rollout and rollback means uh, like in a production setup, or in a production setup, we may need to deploy applications based on the requirements from the client. So we may need to deploy the changes on a daily basis, on an hourly basis, on a monthly basis. If something went wrong, Kubernetes help to roll it back. Okay, so everything is possible with orchestration, load balancing, automatic rollout and rollbacks, self-healing, secret management, everything that can be possible with orchestration or Kubernetes. Okay, so I will show you the Kubernetes architecture also. Just a brief idea about the or the high level overview of the Kubernetes cluster. So for the Kubernetes cluster, we should have at least two machines. A machine where we install Kubernetes, and other machine which is called node or worker node, in which we configure our containers. So here we can see three machines, the control plane, node 1 and node 2. Okay. So the control plane is the machine where, where we installed Kubernetes, and node 1 is and node 2 is the worker nodes where we configure our containers. Okay. So in which we need to install Docker engine or Docker container runtime we need to install in the node 1 and node 2. So the control plane will manage the node 1 and node 2. We don't need to worry about, we don't need to do anything manually. Once we, once we set up the things correctly, the control plane will manage all the machines. Everything will be managed by the node 1, the control plane. Okay. I will show you a quick demo of how this will work. This may be a little bit like confusing for you, but I will show you how this works. Okay, but to get a simple idea, so that's why I'm demoing this one also. So in the kubernetes.io, you will get everything you will get it from the kubernetes.io. Okay. So here, I'm just writing a file. Oh, sorry. You don't need to worry about that, the lines that I am copying here. Okay. You only need to know what it is happening, what cues. Okay. You don't need to worry about the commands. kubectl kubectl apply minus f deployment.yml. So when I execute this command, you can see kubectl get ports. So when I execute this command, it will automatically create 3 containers in my machine. You can see it is getting started. Container is in the creating state. So here I did only created a file, and I have specified some details into that. So when I when I applied that command, what it did is it created 3 containers in my machine. So what I am going to do is kubectl delete. Using this command, I'm deleting one of the container. Okay. So I'm deleting one of the container. So this is the container that I deleted. So now when I check again, there are 3 containers. So what the Kubernetes will do is Kubernetes will automatically check the number of containers, because in my file I specified I need 3 containers. So it continuously monitor, and also if I want to delete some other containers also, then again So if you delete the containers again and again, what will happen? The system will automatically create the other containers also. Here you can see the age. One is 91 seconds ago, other one is 39 seconds ago, and the other one is 3 seconds ago. So the system will automatically create the containers if it deleted automatically, or even though if we delete the container, then system will automatically create the other containers also in our system. This is actually what happens in Kubernetes. So I just want to show you how this is Kubernetes orchestration is happening in containerization. Okay. Any questions? So if you have any questions regarding the Docker Compose, or the Kubernetes, during this session, I have given a high level overview of that Docker. So if you have any doubts, you can raise your question. So based on that, I can explain. Even though if it is a simple question, yes, please raise your question. Don't hesitate to ask questions. Jwalit, Dia, Mithun. No questions. And Jwalit, do you want me to explain any of the topic that we explained into today's session? Do you want me to repeat any of the topics? No, right? Okay. Hi, Sijin, are you there?
Yes, Jolsna.
I'm almost done with my questions. So actually, I planned for a question answer session, but no one is asking any
Okay.
questions.
Fine. If there are no questions, then I think we can end the session. Please note,
Yeah.
everybody, today is our last session. Okay, we won't be having any more classes, but make sure you complete all the quiz and the activities that are there in the LMS. Okay, so make sure you complete them. I think in maybe in a week, so your LMS will end. Okay, so make sure you complete all your activities, your certificates, and your participation certificate and your internship certificate will be ready in the LMS. Will be communicated to you in the coming days. Okay, so make sure you check your mails regularly. Also, the group, it will be communicated to you in these mediums. Okay, so once the certificate is ready, it will be informed to you. Okay, but make sure you enter your task and activities in the LMS and keep it so that you will not have to rush at the last minute. Okay? Thank you, everybody. Thank you for attending the session, and this will be the end of our the program. Okay, today is our last session. So thank you all for joining these days for this. See you. We'll hopefully see you again. Thank you and have a pleasant evening.
Thank you. Thank you.
Thank you, John, for this session.